Okay, in this video, we want to start at least solving some of the problems, some of the types of problems that you might encounter when attempting to take limits. And this will just be kind of like an introduction to these kind of problems. And we're going to prepare more videos here, and hopefully we'll have several sets of different types of problems. And I feel it's necessary because there's no really one set of rules that you can use to solve all the different types of limit problems that you might encounter. They're just like basic sets of strategies involved. Now sometimes when you have a problem, say like you have t plus 3 divided by t plus 2, and you want to take the limit of this, say as t approaches 2, all you have to do is take this value of t, plug it into what you have here, and you get your answer, which in this case is just 5/4. Other times, most other times, you're not that lucky. In fact, many times you will get an answer of 0 over 0. And that does not necessarily equal 0 now. Remember, if you have, say, 8 divided by 4 equals 2, the denominator times this is equal to the numerator here. Well, this could be 0, or it could be 10, or it could be 100, or it could be negative 1 over 37. So when we encounter 0 over 0, that simply means it's indeterminate, and it is not a satisfactory answer. Suppose, for example, we have this kind of a problem. Say we have x squared minus 25 divided by x minus 5, and we want to take the limit of this as x approaches 5. Now if we try just plugging it in, here we will have 5 squared minus 25 divided by 5 minus 5, and we get 0 over 0. In these kind of situations, one thing we could look for to see are there ways that we can simplify the expression. Up here we've got the difference of two squares, so you can rewrite the problem like this. This would be the limit as x approaches 5. Up here we have x minus 5 times x plus 5 divided by x minus 5. So these cancel out. Now when we plug in what the limit of x is, 5, this equals 10. And that's what the limit of this is, obviously, because you're the same expression. So sometimes you come up with a nonsensical answer. One way we can get around it is by doing a simple factorization. Let's see. Suppose it was like this. Suppose we had this problem, x minus 5 divided by x squared minus 25. And we're going to take the limit again as x approaches 5. And if we do that, clearly we're going to get 0 up here and 0 down here. But we can rewrite this. This is x minus 5 times x plus 5. These cancel, and now this will equal 1 over 10. So again, one of the things to look for when you get an answer that doesn't make sense, just by plugging your limit right into the problem, is see if there's a factorization that can help you out. Let's look at this one. Suppose we have x squared minus x minus 2 divided by x squared minus 1. And we want to take the limit of this as x approaches 1. Now that would give us 0 down here, and we would have minus 2 up here. It looks like we can do some factoring here maybe, so this would be equal to, up here we could write as x plus 1 times x minus 2. And here we have the difference of two squares, so we have x plus 1 times x minus 1. And these will cancel, but now we're taking, as x approaches 1, this would be 1 minus 2, so this would be negative 1 on top, but we're still getting 0 down here in the denominator, which would equal minus infinity. So the limit for this expression as x approaches 1, there isn't any. It's undefined. No matter what we do, we still end up with a 0 in the denominator. So in this case, at least for x approaching 1, this function here has no defined limit. Suppose we have a problem like this, where we have 5x cubed plus 8x squared divided by 3x cubed minus, say, 16x squared. And we want the limit as x is going to approach 0. So if we plug in 0 for x, again we're going to get 0 up here and 0 down here. So we're getting 0 over 0 indeterminate. It doesn't look like there's any factoring that would do us much good. But notice that in the denominator we have x squared, down here we have x squared, and here we have x is to a highest power. So for the numerator and the denominator, the lowest power of x that occurs is x squared. So what if we multiply the top of this numerator by 1 over x squared? And of course we have to do the same thing for the denominator. Multiply by 1 over x squared. And then this will be equal to 5x plus 8 is divided by x squared. And then here, this is divided by x squared, so that will be 3x plus x squared divided by x squared. It's just 1. This will be actually minus 16. Now when x becomes 0, these go away, but we have these left, 8 over negative 16. So that limit there is actually minus 1/2. So here we've shown, I just want to give some quick examples just to illustrate these points, that sometimes you can factor a limit out and you can get an answer then. Sometimes, as in here, you still don't get a reasonable answer. It still blows up on you, in which case there simply is no limit. Or sometimes you look at it and maybe by dividing through by a power of x helps get it into a form that gives you a reasonable answer when you make your substitution. And the best way to get a feeling for this is just to work a bunch of problems. So we're going to post more videos, we'll work more problems here, and we'll try to include some more complicated examples as we work through more and more problems. So come back, join us for some more videos, and we'll try and solve some more problems.